Alrighty, hello and welcome to lesson 4.2 of the Origami Design Class. The last video was super important, and this video is going to be just about as important. And if you already know how to pack, I still think you should watch this video because I do have one thing here that Robert J. Lang does not have in his book. And that is how to estimate the ballpark grid size you're going to need, which is going to be equal to the sum of tree lengths times 2 divided by 4, which is, well, I'll explain that more later. But for now, let's get into it. So in the last video, we did some sacrilege and we kind of learned what is a packing by deconstructing an existing tree. And in this video, we're going to do the opposite. We're going to take the tree and turn it into a packing, which will allow us to turn it into a crease pattern. And when we fold the crease pattern, we will get this tree. So make sure to watch that video. This video will not make any sense if you don't know the stuff from the past video. I'm going to be designing with as you can tell, I'm going to be using pencil and paper. I'm using a pencil instead of pen because when you're designing, you have to go back and fix mistakes. So I'm using a pencil. I'm not using Origami because so it's a little easier to write numbers and do some math, and I have the physical model I've been doing, so this is just easier. But I normally would do this in Origami, but just for the sake of showing it, it's easier than doing a screen recording, so I'm just doing it on paper. I will later show you an example of how to do this packing with BP Studio and with TreeMaker combined. But for now, I'm going to show you how to do it by hand. Kind of like when you're learning math at school, right? You need to learn how to do addition. And once you know how to do it, it's okay to let the calculator do it for you. But if you don't know how to do it yourself, it's a bit of a problem. So let's say you wanted to you're trying to design something. Let's just say like a crab or something. And your traditional bases aren't working. You don't have enough flaps, or your flaps are not the right proportions. You want to make your own base with your own flap lengths and your own everything. So for example, if I were making a crab, I would do something like this. So I would have these long flaps for the claws, and then they would have these little, the V shape, and then a bunch of legs. I think 8 legs, and then maybe some little small ones for the eyes or something like that. And then I would go in and I would assign lengths, so maybe like 6, maybe 8 here, something like that. I would have to tweak these lengths, but for now, that's the general idea. And then I would pack it in. So here I've got this random tree, just for the sake of example. This tree is pretty simple, but in theory, you could go out and design your own tree, and then pack it based on what you learn here. All right. So the first thing we need to do is just get an estimate of what grid size we're going to start packing into. And we'll expand it or maybe shrink it later, but we just got to get something to start with. So to figure out what grid size you should start with, you have this rule here, that the grid size must be greater than or equal to the sum of the tree lengths times 2 divided by 4. And I know this is the same thing as divided by 2, but I write it like this because it's a little bit easier to understand why we do this. So sum of the tree lengths includes rivers and flaps. You just add up. So 3 plus 4 plus 5 plus 3 plus 2 plus 2 plus so on. I did this earlier, and I counted, I think, 30. We need to find a minimum grid size, baseline, starting point. So we're not just drawing in midair. So I added up all the lengths, and that's 30. So then we would take 30 times 2, which is 60, and divided by 4, which is 15. So minimum, the very minimum grid size we're going to need is 15. But I don't like 15 grid size, and it's going to be very tight to pack it into 15 grid, and it will need to be 100% perfect. So I'm going to give myself a little bit of extra room and make it a 16 grid, which is also a little bit easier to fold from. Now the exception is with center flaps. If you have the sum of tree lengths minus whatever center flap. So if you're like making a skeleton and I know these ones need to be center flaps, or like a squid with the big one in the middle, you can subtract that one out. But center flaps make everything weird, and especially for smaller trees like this, more often than not you can get by without center flaps. It's not until you're maybe around when your minimum grid size starts getting to around like 20 or so or higher, then you're probably going to end up with some center flaps. But until then, you're probably fine. I'm going to prove to you why this theorem works. If you don't care, you can skip ahead to this timestamp. Otherwise, let's take a look. So I have this simple tree here. It's 2 units on the flaps, 4 units on the river, and it's an 8 by 8 grid. So the way this theorem works is it counts units of edge that each flap and river takes up. So let's look at these 2 unit flaps. How much edge does it take up? So let's just say n for the length of the flap. So this one takes up 4 units because it takes up, this is length n because the flap length here, another length n, so 2n. And then this also takes 2n, and then, the river is worth 4, and the river is also going to take up 2 times 4, because you need an edge here, so 4 unit edge here, and then 4 unit edge on the other side. And same thing for all the flaps. So basically, the number of edge units that a flap takes up is twice its length. The number of edge units that a river takes up is twice its length. So if we need to figure out the total number of edges that this whole tree is going to take up, we can just add everything and times 2. So that's what this is. Sum of the tree lengths times 2. This is basically how many edge units it's taking up. So then we say, okay, if you have a 6 by 6 grid, so like here, what's the perimeter of this? It's going to be 4 times 6, right? Because if I have like a 7 by 7 grid, what's the perimeter of that? How many edge units will be in here? It will be 4 times 7. So basically, we can just take this and divide by 4, and that will tell us the size of the square, the side length of the square. And that's basically what we're doing. So in our example here, we have 30 tree lengths. Times 2 means we will need 60 units of edge, and a 15 grid will provide that for us, because on all 4 sides of the square will be 15 units. So if we pack everything perfectly, a 15 grid should suffice. But a 16 by 16 grid will give us 4 units of edge to spare in case we need to, you'll see we'll end up using these extra edges. Okay, with that being said, so I've drawn in my 16 by 16 grid. We may need to expand it even more, or we may be able to shrink it. We'll see. Okay, so here's one tip. One tip is to start, if you don't have any other conditions, like sometimes you'll be like, okay, I need legs in the corner for this, and this reason, or I need the head in the center for this, and this reason. If you have those conditions, you want to start with that. But for this tree, I just want to pack it. I just want to make this stick figure because it's, I don't know why, but I do. I'm going to start with the biggest flap. So here, it's a 5 unit flap, and there's a bunch of big flaps next to it. So I'm going to start there. So usually you want to do big flaps in the corner. And the reason why that is, let's consider the following. Let's say I got this 4 unit flap in the corner, and I got this 1 unit flap on the edge. How much area is this taking up? So this corner flap, let's remember, track the hinges. So the is taking up a 4 by 4 box. So this flap is taking up 16 units. And this flap, we'll ignore the pleats. This flap is just taking up 2 units. So in total, we're taking up 16 units, aside from the pleat. So we're taking 16 units here. Now let's say on the other hand that I had a 4 unit edge flap. So my big flap was put on the edge instead of the corner. Already, you can see that it's taking up a lot more. It's now taking like 2 times 16, right? It took up, well, half the paper. So it took up this whole half thing just for this top edge flap. So that's 32. So that took up way more space. We're going to have less room. It's going to be thicker. So overall, not good. It's taking up too much room. So we don't have enough freedom. So we're going to start with the big flaps and prioritize them into the corner. That's, again, this is just a general rule of thumb. So I'm going to, remember we're drawing ridges and hinges. And I'm just doing the pencil instead of color because in case I have to change it later. So here's this 5 unit flap. And then what happens next? Then I need to start, so I'm going to ignore the river for now because I haven't drawn everybody above the river. So I need to draw the 4 and the 3. Also keep in mind, Tree Maker will do this, you do not want to do this. What I would not want to do is draw the 3 here and then the 4 after. Unless, it depends on the design, but typically you don't want to do that. You cannot twist the order. So like when you're going around the edge, you want to run into the correct way. Again, you'll learn this by experience. Like I learned this when I was a kid trying to design. I learned that you cannot just swap the flaps. Anyways, so I need to draw I started with the 5. I need to do the 4 next and then the 3. So the 4 is going to be an edge flap right here. And okay, that's nice. It leaves us just enough room to make a 3-unit corner flap right there. So let's go ahead and count how much edge we've used up. So we've used up 5 here, 5 here. That's to be expected, right? Remember, each flap will use up twice the number. So a 5-unit flap should use up 10 units, which we have here. This 4-unit flap has 4 here, 4 here. That's also to be expected. But this 3-unit flap is only supposed to have 6 units. But we're taking up 3 up here. Oh, I forgot to draw hinges. That's why. That makes things a little easier. So it's got 3 up here, but it's got 5 over here. So it was only supposed to have 6 units, but we actually are taking up 8 units. And so these like 2 units here, this is the reason why we need to have a grid that's a little bit bigger than 15. Because if we were 15, and if we were on a 15 grid, we only had exactly 60 units, and I used up 2 extra here, that means some other flap is not going to have enough space. But because I bumped it up to 16 grid, I have 4 units to spare, so I've used up 2 of them here. I'll have 2 free units later somewhere. Okay, now we got a river here, a 3-unit river. So the river will separate, so these 3 flops on top will be above the river, everything else below the river. Now remember that rivers must run from edge to edge or loop back on itself. Edge to edge or loop back on itself. So what would not be okay is if I just put a flap right here and had the river run into a flap. That's not okay. You cannot do that. The river must continue all the way to the edge or loop back on itself. Also note just some general rules, like I should have explained it, but the other rules are that the center of the flaps must be in the square. So just the center. The rest of it can be outside the square or so. The flaps cannot overlap except for Pythagorean stretches, which we'll learn later. Otherwise, the squares cannot overlap. The river needs to stay the same width all the way through. Like you cannot be, oh, now it's 4 units. You can't do that. Also notice that I'm not leaving any gaps. Like if I had tried to make my 3-unit flap up here and then just left this 2 by 3 region empty, you can't do that. You cannot do that. So you need to move them around so that they fill up all the gaps. So in this case, I'm going to do it. And then this crease is optional. It could just be a pleat or so, but you need to fill in all your gaps. And when we do BP Studio, this might be a little bit easier. All these rules are already programmed in. But when we're packing, I hope this is making any sense. Packing is really hard to pick up at first. Next, we got this branch here. We've actually got our choice of branches. So we could move on and do this whole thing, or we can do this thing. And as I said before, we're actually going to start with the bigger one if we can. So I'm going to do this 2 river here, this river. But there's no order. We don't have to do this one first. We can do this one because, they're both connected to this river either way. I'm going to start with the river. Last time I said we had to wait until all the flaps are done before I do the river. I'm just going to get it started. I don't know where it's going to go, but I need to designate, like, this needs to be, the next flap that starts here needs to be at least 2 units away from the river here. So I think this is okay. I think this is okay. You see, I've used up my 2 extra units here, so now I'm on the line now. Yeah, let's just give it a shot. Let's hope I get lucky. So here's my 4-unit flap. So remember, that's this 4-unit flap here. And now I'm going to pack on this 3-unit flap. So remember that these extra pleats here, these are okay. So actually what I'm going to do is I'm going to move this one. I'm going to make my river, okay, I'm going to put my 3 unit flap like this actually. So instead of putting it up here, I've now shifted it down, so now there's no extra pleats on it. The center is just on the edge, rather than having the center up here. And what that allows me to do is it allows me to have my river, I can have my river run like that, and close it off. Now as it turns out, that's actually not necessary. I take it back, I've foresaw ahead. Okay, you know what, never mind. Let's leave this here. Okay, now let's go ahead and pack our last branch. So we need to do this 2 river with the little 2 things on it. So again over here, I don't know what my river is going to do, but I'm just going to mark right here that it's going this way, right? So and then the next flap needs to start 2 units away from the river. So we got a 2 unit flap, so edge flap and corner flap. So we clutched this one. It barely worked. Okay, and then the river can just go down and around, so like this. And then remember, every time the river bends, we need a ridge like that. So we got here's our 2 unit river, and it's separating off these 2 flaps. Now what are we left with here? We are left with this big gap. How do we fill this in? One way we can do is we can have this river bend the way it was before. So this time we can have this river go like this, and then just shift this flap up. So like this, something like this, and then so if we had it like this, our packing looks like this, then this would work. So here's our 2 unit river separating off these 2 flaps. This could work. Another way you can do it, and this is nice for color change designs, which I may or may not be allowed to talk about this, but if you don't like having these pleats on this edge flap, you can keep it down here and shift the thickness of the paper into the river. And what I mean by that is instead of making the flap take up the space, you make the river take up the space. So you do this by having it go like this, or something like that. So I actually don't know if it's possible in this case. It looks like it's not completely possible, but in any rate, you can kind of take up space by bending rivers. Here we didn't fill it up completely. There's still this box here that's unfilled, but you get the idea. So I'm actually going to have to go back, and that's why I'm using an erase here. So you see that this is not a staged packing. I had never done this until filming the video. But you see, there's going to be a lot of thinking. You're going to have to go back and undo things. Just make everything fit. It's an engineering. I would argue it's an engineering. It's an optimization problem. You need to make everything fit into. There's constraints you have to follow, different specifications. This is an engineering problem for sure. So here is our finished packing. So we've got this 4 unit flap and 3 unit flap in here, separated by a 2 unit river. We've got these 2 flaps here that are both 2 units each, also separated by a 2 unit river. And then all these guys are separated by a 3 unit river. And above are this 5 unit flap, 4 unit flap, and 3 unit flap. And we've used up, we definitely needed this extra buffer edge units. Otherwise it would have been very hard on the 15 grid. Now to actually go fold this, I'm just going to use this one here. It's on 8x8 grid right now, so let me just pre-crease a 16x16 grid, which by the way, I will show you how to fold through the layers. So I like to fold so that's showing the white, and these open layers, I'm going to fold it up like this, and this will prevent them from sliding around. Okay, so you want to make sure they don't slide, and then you can kind of pre-crease your grid by folding through the layers. And again, you don't want to do this for your final fold, but for a test fold or just proving something that doesn't really matter how nice it is, this works. This will save you a lot of time. And there I folded in 16th there, and that was a few seconds. So let me just do the same over here. So start with the edges one. Be super careful on this one, and then that will make the rest of them a lot easier if these lock together. And I'll just eyeball this. So there's our grid, and I think you might have learned this in Boyce's class, or you already know. But to fold this, we're just going to fold the ridge creases. Those are really the only ones you need to pre-crease, and I apologize because it's might get a little distracting because I already had some diagonals here. But just go ahead and pre-crease in the diagonals, the ridge creases. So there's the top ones. Ones like this are optional. Don't worry about those. So 4, and then 3, and 5, because 3 plus 2, and then 4. So I'm counting the length of the ridges, so it makes it easy to pre-crease. And then 2 and 2. Now it's just a crease CP collapse. So I assume you know at least somewhat how to do this. I'm going to start from the bottom because there's some a little bit more complicated on the bottom. Just a little bit more complicated. Complex, I should say. This is not complicated. This is complex. And complex just means there's more parts. Complicated means it's hard to understand. Which is not. Crease patterns are fun. And they're not that hard to understand. With practice. Okay, and you see on the top, I'm not going to worry about collapsing these ones yet. I'm just going to leave those as pleats while I collapse the bottom. And then from there, I can alia stretch all the ones on the top. Now, we actually skipped a step. I remember I said in the previous video that you need to go from packing to crease pattern. Once you get a lot of experience with packing, you'll be able to just fold the packing right now like we just did just now. But in case you were wondering, we will go in and figure out how do you draw the crease pattern. Like once you've folded it, of course, like we can just draw this. When you draw this crease pattern based on the packing, you'll need to know what is an axial crease, hinge crease, ridge crease, axial plus 1, and then yeah. So we will need to learn those. In a future video, we will figure out how to go from this into a crease pattern. But for now, I just wanted to show you that I just wanted to fold it. Hopefully you're able to follow along. If you're able to follow along, if you could have folded that from the packing, let me know. But I just wanted to show you that it does indeed turn into the crease pattern, into the tree that we needed. So I hope you can see that this is 3, 4, 5. And you see that if we had swapped these, we would not have been able to like twist them back. That would not work. But yeah, so we got our 3, 4, 5, 3 unit river, 2 river, 2 flaps, a 2 river here, and then 3 and 4. So it did indeed make the tree that we wanted. And so if this tree were something that was supposed to turn into an animal or a human figure or something, I would then be able to shape them and start thinning them out or whatever I need to do to make it look like a finished model. Let me just, normally I would type this, but I'm going to handwrite the rules. So I think these will be in the slide. I will link the slides in the description. I didn't actually use slides today, but basically, okay, 1, the grid size is going to be greater than or equal to the sum of the tree lengths minus whatever length of center flap. You can ignore this for now. But basically sum of that times 2 divided by 4. Rivers must go from edge to edge or loop back on itself. So an example of that, I don't think I explained that, but an example of that is like, let's say I had these 2 center flaps, and then I had a river that went around it. And then that would look like the river, just there's one river there, and then, whatever else. So it loops back on itself, and that's fine too. Flaps cannot overlap without a Pythagorean stretch. So basically just don't do it until we learn it. You may see Pytha, this is what is called. Pytha is a Pythagorean stretch. The center of the flap must be in the square. Every unit must be a part of a flap or a river, so no unfilled gaps. So again, you can fill in your gaps by meandering your river. Yeah, you saw it up here. It's like, let's say I made my river go like this. If I made my river go like that, then I filled up some extra space. If that makes any sense. Lang talks about that in his book. Or you can also add extra pleats onto the flap like this, and that will help you fill in extra space. So yeah, I think those are the main rules. But for now, let's take a look at what we can do for homework. I will give you a few trees as practice problems, and your job will be to pack them, and then you can send a picture of the packing, or you can actually fold it and send a picture of that. And if you send a picture of the packing, you should spoiler it in the Discord. That way people, it's like solving the answer to a riddle. Don't spoil it. Let them people solve it for themselves. Let me just draw a few trees right now. So maybe these are just random. I'm just going to make them up on the spot. Okay, so this is a weird tree. 3, 2, 3, 4, 1, 1, 2, 3. If you can't see the lengths. Okay, maybe I'll give you 3 in total, and you can pick whatever one you want. Maybe let's do one that looks like an animal or so. You know what? It's the year of the ox. Let's make an ox. So ox has, I'm going to look at it from the top view. So maybe a 3-unit tail, and then let's give it 4-unit legs. Body, let's do 3-unit body, 4-unit legs again, and then for the head we'll do 2-unit neck, because that's going to need some shaping, 2-unit horns, and then a 2-unit snout. So notice how I did it from the top view, because if I did it like this, you would have probably put the legs on the wrong side or so, or it would have been confusing. So I do it like this so that you can show that it's supposed to be symmetrical. There's going to be one leg on each side. So give this a try. Pack it, You don't have. It doesn't actually have to be symmetrical. You can pack it as however you want. Also, in this video, you're not required to shape it. You don't have to shape it. We haven't really learned that much, but if you feel up for it, you should give it a try. It's fun. I've got this. Okay, this last one is going to be kind of a joke, and you may see why or may not. But basically, we're going to make a squid, and if you know where this joke is going, you know where the joke is going. Don't forget about center flaps. So there's a 4-unit head here, okay, and then there's going to be these are all 4 units each. And then this will be our squid. These are the 3 trees you can try. 2 out of 3 of them are going to be good exercises. But we got a random tree, we have an ox, and then we have this thing. So you can take a screenshot of this, write them down, draw them in Origami. Use BP Studio. If you know how to use BP Studio, you can go ahead and do that. Otherwise, don't worry about it. You can pack by hand, pack on Origami. You can send in the screenshot. You can send in a screenshot of the packing. You can send in a picture of the CP. You can send in a picture of the folded tree. Whatever you want. Just practice what you learned today about how we packed in the tree. Again, I know I didn't really explain it super well, but I hope that one clear example will make things a little bit easier. Give it a shot on the homework. If you have any questions, like if I was super unclear or anything, you just got stuck, you don't know where to start, don't be afraid to join the Discord, ask me any questions, or other people there will be there to help you. And we respond pretty quick too. In the next video, when we'll look at the homework submissions. I didn't get a chance to review the grafting homework. We'll go over that too in the next time we look at homework. So give it a shot. Alright, so if you found this video helpful, if you learned something from it, and you want to keep making these videos, the best way you can help me out is by liking the video and subscribing, and also sharing the video with people who you think might appreciate the video also. So thanks for watching, and I'll see you next time.